Negative exponents. In this video, we will review why negative exponents behave like they do and how to simplify expressions with negative exponents. We want to take expressions such as these and be able to simplify them so that we don't see any negative exponents in our final simplification. First, let's look to see a pattern before we go into what to actually do with negative exponents. You should have filled out this chart in class, but in case you missed it, I'll fill it out now. Everything you see in black are facts that you already know. You know that 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4, 2 to the 1st is 2. And we notice that the pattern is that every single time, if we go down, we are dividing by 2. This makes sense because every time we've increased our exponent on the 2, that means that we would multiply by another 2. So if we decreased our exponent every time, that means we wouldn't multiply by one of our 2's. If we continue our pattern of dividing by 2 every time, we notice that 2 to the negative 1 is 1 over 2, or 1 over 2 to the 1st. 2 to the negative 2 is 1 over 2 to the 2nd. 2 to the negative 3 is 1 over 2 to the 3rd. And this pattern also holds true with 3's. If we decrease the exponent on the 3 every single time, it means we're multiplying 3 by itself one fewer times. So if we divide by 3 each time in this column here, we end up getting 1/3 for 3 to the negative 1st, 1/9, or 1 over 3 squared for 3 to the negative 2nd, and 1 over 3 to the 3rd for 3 to the negative 3rd. We notice that we have reciprocals for 2 to the 1st and 2 to the negative 1st, or 2 squared and 2 to the negative 2, and this pattern will always continue. From this, we can conclude that a to the negative n is the reciprocal of a to the n. In other words, a to the power of negative n is the same thing as 1 over a to the n. This holds true as long as a is not 0 and n is a natural number, or a positive integer. So let's apply this to a few basic cases. If we have 3 to the negative 2 and we want to simplify it, well, I know that I could relocate that to 1 over 3 squared and then simplify from here. So that's 1 over 9. Similarly, if I was given something such as 1 over 5 to the negative x, well, I know that I could relocate that 5 to the numerator and get rid of the negative sign on my exponent. When I see a negative in my exponent, I simply relocate any base with the negative exponent to the numerator or to the denominator, wherever it is not already. Caution, this does not make the expression negative. We have a positive 1/9 here, and we have a positive 5 here. You would need a negative with your base in order to have a negative expression. Now I'll go through those 3 examples that I had earlier in this presentation. Keep in mind, this video should not replace learning this concept in class, but it's a good refresher, or it's good if you miss class. So the first one says x to the negative 3. That means that I have an x as a base with a negative exponent, so I'm going to relocate that x to the denominator and keep my exponent as a 3. This can't be simplified any further. The second problem says 2x to the negative 4th. As we've discussed in class, I'm going to write a 1 as the exponent for that 2 so I don't get confused. That means that in my numerator, I'm still going to have a 2 to the 1st, but the x, which has an exponent of negative 4, is now going to, relocate to the denominator, and it will have an exponent of 4. Now this last expression I could approach in a few different ways, but I like to always simplify inside my parentheses first. You'll find different strategies that work for you, but I like to do this to be consistent. So first, my inside, I see that I have a negative 5 over 10, so I'm going to simplify that to negative 1/2. My expression in there is staying negative because there is a negative sign. Then I have an x to the 4th in my denominator and an x to the negative 2 in my numerator, So I'll move that also to my denominator. My outside stays the same. You might notice that I could simplify this inside even further, and you may have done that in your head, but I'm writing it out separately. So I have negative 1 over 2x to the 6th. Now from here, I still have to apply this negative 3. I can either take this and apply the negative 3 to the negative 1, to the 2, and to the 6, remembering that I would actually apply it to the exponent of each of those. So it would be the exponent of 1, the exponent of 1, and the exponent of 6. Or I could take the entire parentheses and take the reciprocal of that parentheses. So that's what I'm going to do. I'm going to change this to 2x to the 6th over negative 1 and still put that to the power of 3. Because I've taken the reciprocal, I can keep the exponent of 3 on the outside and now apply it to each part inside. Now because I have a 3 on the outside, that means that I'm going to have 3 groups of this entire inside expression here. At this point you can probably do this without writing it out, but I'm going to write it out anyway. I have 2x to the 6th over negative 1 times 2x to the 6th over negative 1 times 2x to the 6th over negative 1. When you see this expression, even if you don't write it out, the first thing you should look for is the sign. In this case, I know that my final expression is going to be negative because I have an odd number, or 3 groups, of a negative. The denominator here is negative 1, so we actually don't even have to write that there. If it had been a different number, we would write it in. Then I have 2 times 2 times 2, or 8, because we had 2 to the first, so now I have 2 to the third when I apply this 3 to this exponent. And then I have x times x times x times x times x times x, and that same thing 2 more times. So in total, I have 18 x's. In other words, I apply this 3 to this 6 here, and I multiply them together. This is a much more complicated example than I would typically start with, but I wanted to include it for those of you that were absent, or for those of you that are watching this later to review for your test. In summary, when we see a negative exponent, that tells us that we relocate whatever our base is to the numerator or to the denominator. So x to the negative 3 is 1 over x to the third. 1 over x to the negative 2 is x to the positive 2 in the numerator. And 2x to the negative 5, we keep our 2 in the numerator, but we would only move the base that has a negative exponent with it. You will notice the patterns as you start to practice these more. And you'll see that you can either relocate first. For example, I could take this expression and keep it x to the third over x to the fifth relocated, which is 1 over x squared. Or you could use the patterns that we've been using and that we've discovered over time. And since we know that we would typically add these exponents together, we end up getting x to the negative 2 by adding 3 and negative 5. This, of course, is the same thing as 1 over x squared, and either way we would simplify to this. I hope this helped you in your understanding of negative exponents, and you can always come in with questions if you still have them.